There we go. Yeah, this is the last thing that we're going to do on section 5.2. All right, so it's 5.2b. Let's review briefly. Let me remember when we get out of here. 21. Okay, I got a little less than 20 minutes. Right there is fine. Take those off. Oh, that's a note. Gotcha. What's that? Okay. All right. I'm worried about teaching right now, so let's look up here. All right, let's review briefly, and then we're going to talk about the centroid and how to find the centroid and all that good stuff. All right. I've told you this several times. I'm going to tell you again. And you are taking the quiz on Friday, and this is going to be on the quiz. The first 4 questions on the quiz, okay, are basically going to be what I'm writing down right now, okay? So I've told you already, but I'm going to do it again. So the very first thing, remember we said he had 4 words? Today we're going to do the 4th word. Centroid is the 4th word. What was the first word we dealt with? Nope. Well, it had to do with the word, but what was the, remember, nope, that was the second one. Yeah, but that formed the what? The point itself. Yes, it's the circumcenter. What word am I trying to think of? Concurrent. The point of concurrency. Remember that word? The point of concurrency, where those lines intersect each other. Okay, the first one was circumcenter. But how did we find the circumcenter? Is this review a waste of time? Looks like it is, because a lot of people talking and not paying attention. This is a review. This is going to be on the test on Friday, on the quiz on Friday. So, the first thing that we did was perpendicular bisector. Okay, so if I found the perpendicular bisector of all 3 sides of my triangle, those 3 lines intersect at one point. What do we call that one point where they intersect each other? You guys thinking? Or are you just staring off into space? The circumcenter. All right. So write that down. That's the first thing that we did. Found the perpendicular bisector of all 3 sides of the triangle. We found the circumcenter. So circumcenter is the word on the quiz. That's going to be one of your answers on the quiz. Okay, I'm going to say, it's a little wordy, but I say something about the point of concurrency, finding the perpendicular bisector. So when you see perpendicular bisector, automatically your mind should go to what? Circumcenter. Okay, what was the second one that we did? Altitudes, that's right. Okay, altitude. So when you find the altitude, what is the altitude? Goes from a vertex perpendicular to the opposite side. So when you find an altitude, all 3 of those are going to intersect at one point. And we call that the orthocenter. Okay? Yesterday, we talked about finding the what? The angle.
Angle bisector.
Very good. You like that one, don't you? All right. So it's the angle bisector. So if I took a triangle, we just did a problem, right? We just went over a problem that had an angle bisector on there. If you do it to all 3 angles, they all intersect each other at one point, a point of concurrency. What do we call that? What do we name that point of concurrency?
You need a letter.
Nope, not, because we just went over it. It's the incenter. Okay? So that's called the incenter. Now, today, we talked a little bit at the end of the period yesterday about this, but we're going to get into it a little bit more. It is going to be the centroid, but how do we find the centroid? What do we do to that triangle? It's the median, that's right. We're going to talk about that a little bit more detail today. We kind of hit on it a little bit yesterday. So if you find the medians of the triangle, all right, they all intersect at a point, and that point is called the centroid. So that's your first 4 questions, basically. Now, I could switch the order. I'm not necessarily going to put circumcenter first, ortho second, incenter, and centroid in that order, okay? I'm going to mix them up a little bit, so you have to think. But you just have to know that perpendicular bisector goes with circumcenter. This would be your answer, circumcenter. I'm going to talk about the altitude. What word goes with altitude? Orthocenter. What word goes with angle bisector? Incenter. What word goes with median? Centroid, okay? And we're going to talk about the centroid a little more detailed today. Everybody with me? That was all review. But it's going to be on the quiz in 2 days, right? All right, so make sure you know those words. I don't know what else I can do for you. Do you have to be a math person to be able to get those right? No, because people tell me all the time, well, I'm just not a math person. Well, a lot of people aren't math people, but they still learn it, okay? So don't use that as an excuse. All right, make sure you know those words. Now, let's talk about the median. So let's draw a triangle. It's going to look like a very familiar triangle because I'm basically drawing the same shape for every one of these. It doesn't have to always be this shape, but this is the easiest version of it. All right, so we're going to call this, just call it ABC. Whoops, ABC. Watch what I'm going to do. This is very reminiscent of the first one. Reminiscent. You ever hear that word before? Okay, reminds us. Okay, reminds us of the first thing we did. All right, the very first thing we did, we found the perpendicular bisector, correct? Which means we bisected each side. We found the midpoint, correct? Yeah. So I'm going to put a midpoint on all three of these sides. Yeah, let's do it to all three of them. All right, so there's the midpoint right there. Put a little point right there. And then there's the midpoint right there. It's a nice thing about this program is it shows me exactly where the midpoint is. So that's nice. Now, check this out. This is the median. We talked about it yesterday. We're going to talk about it again today. The median is this. Everybody watching? All right. It goes from a vertex to the, what do you think? Is it going to go to another vertex? Is it going to go perpendicular? Is it going to bisect this angle? No, what's it going to do? Where's it going to hit? At the midpoint. Midpoint, okay, not center. Technically, I know what you mean by center, but I specifically want you to say midpoint for this, okay? So it doesn't necessarily bisect the angle, but it does bisect this side. You with me? So if that's the midpoint, that means that this little segment and that little segment are equal to each other. So what did I just draw right there? What did I just draw in red? What is that? No, it's a median. It's a median. Because it goes from the vertex to the midpoint of the opposite side. Okay? Remember we talked about yesterday the road, you're traveling down the road, right? You got that grassy area in the middle of the highway. What do we call that grassy area? Call it the median. Why? Because it's in the middle. All right? That's what this is. That's how you can remember it. Goes from a vertex to the middle of the opposite side. This is not a perpendicular bisector. What would a perpendicular bisector be? It'd make a right angle. See that thing right there? That right there would be a perpendicular bisector. That's a lot different than the median, isn't it? Okay? So they have some similarities. They hit the midpoint, but that's the only similarity. Okay, a median goes where? From a vertex to a midpoint. You with me? All right, so you got to know what a median is first, and now we're going to do this. And we've done this with all three. What do you think we're going to do? I drew one median. What else am I going to do? Draw two more, right? Draw all three of them. And what do you think is going to happen with all three of those medians? They're going to come together, they're going to intersect each other to form a point of what? A point of, C, it's not centroid though.
Circumcenter.
Concurrency. Oh, okay. All right. When did we learn that?
That's money.
We talked about it earlier today. We talked about point of concurrency. Every one of these has a point of concurrency. What was the first point of concurrency? We did a whole review on it. Circumcenter was a point of concurrency. What does that mean? It means where they all intersect. What was the second one? Orthocenter. What was the third one? Incenter. Okay, they're all points of concurrency. So what do you think we're going to have here? Another what? Point of concurrency. Check it out. So when I hit the midpoint there, look what happens. They all meet at a point of concurrency. But we have a special name for that point of concurrency. All right? So look, I bisected that, right? Those are two equal. I hit the midpoint there, bisected it, so those are equal. Let's put 3 tick marks. Mario, what'd you say? Centroid. So that point right there, the point where they intersect each other, has a name, and we call it the centroid. Okay? How did we find the centroid? What's that? Okay, found the median. Very good. Okay, found the median. What is the median? It goes from a vertex to the midpoint of the opposite side. You with me? A lot of words, a lot of geometry words, but you got to keep them straight.
So like you know when we were doing last unit of the video bus, where it was like, oh, if this on the opposite side, the other is on the opposite side. You don't get it, bro.
I'm not sure.
Look at,
I'm not sure what you meant.
Like you know how we did triangle ABC?
Yeah.
Equals triangle BBC.
Yeah, that's different.
So like look, like the opposite of B equals what you said.
It's different.
I'm done, bro.
Good. All right. Come on. I only got like 5 minutes left. Let's watch this. So I'm going to call this XYZ. And we'll call this M in the middle. Everybody with me? This is, to me, this is my favorite one because I think this is really interesting. It's not like people made this up. They just discovered it. Okay, it's not like somebody said, okay, I think I'm going to, have a midpoint here, and I'm going to make sure that it hits in the middle. No, it just happens to do that, okay? Not just happens to. I think it's designed to do that. I told my other class, said in a public school, I would probably have to say, yeah, it just happens that they all intersect at that one point. But I don't think it's just happenstance. I think it's designed. And who do you think designed it? Okay, I think God designed it, absolutely. I think there's absolutely a designer for this kind of stuff. And I think it's absolutely, I'm 100% sure, okay, that God designed this stuff. Now, did he come up with these words, centroid and all that? No, man did that, okay? But the design, the fact that they intersect at that point right there, I think is it's designed in this. I think God did this. All right, so what's interesting about this is, yeah, I'll tell you what. Let's just do this. I'm not going to even have you guess. I'm going to just show you. What if I said that that was 3? I just made that number up, okay? Nothing special about the 3. I just made it up. I could have made it anything. But watch very carefully. Nate, you watching? Watch very carefully. This is what's special about the median and the centroid. Everybody watch? Look at MY. What do you think? I said I wasn't going to ask you what you thought, but now I'm going to. Everybody watching? Not everybody's watching. So this MY, if I made that 3, just take a wild guess. What do you think MB would be? Do you think it would be also 3? Look at it. It definitely is not 3. Would you agree? Because this is way shorter than that. Okay? Owen, you got it exactly right. If the shorter one, right, from here to here, from M to Y is 3, then from M to B, right there, is going to be 6.
Oh, because half of 3. I'm half of 6.
Half of 6, right? Or twice 3, right? Double 3. Everybody see that? So the shorter one is half of the longer one. Or you could say the longer one is what? Double the shorter one. Everybody see that? Let's do it again. What if I said this? What if I said AM was 10?
5.
Then tell me what MZ is going to be. It's going to be 5. Okay? What's the whole AZ? What if I asked you all of AZ? It's 15, right? Because you got a 10 and you got a 5. What is BY? It's 9. Got a 6 and a 3. Okay? Now let's make it up another number. Let's say this was 7. Then MC is going to be 14. What's XC going to be? 21. All right? Check out this. Remember the whole AZ? What's the whole AZ? So what if you didn't know that? I mean, you know it, okay? But let's say you weren't thinking about this. But I asked you, I gave you this one, the short one. What is the whole entire AZ? What did you say it was? What's an easy way to do that? Well, double 5 is not 15. Well, you could double it, but then you got to do 2 steps. Watch. You double it. You got it. You double it. You get this. Then you have to add. That's 2 things you got to do. How do you get AZ in one shot? That's what I'm trying to get you to think. That's what I'm trying to get you to see. So if you know the short one, you can just times it by 3 to get the whole thing. Everybody see that? Because if this was 10, the whole thing would be 15, right? 5 times 3 is 15. Agreed? What's the whole thing here? BY. It's 9. Or you could take the short one, multiply it by 3 to get the whole thing. Right? So watch. Look at XC. Look at XC. It's what? 21. Or you could do what? 7 times 3 is the whole thing. So watch this. We're almost out of time, but okay, that's good. What if I gave you this? A couple ways you could do this, but just trying to figure out the easier way. What if I told you that AZ was equal to 24? AZ was 24. But then I asked you to find AM, all right? Why are we packing up? And I asked you to find MZ. Okay, if you go 24 divided by 3, which one is that? It's MZ. So what is 24 divided by 3? It's 8. So that would be 8 right there. Okay, so MZ would be 8. What would AM be? 16. Because you could look at it 2 ways. You could go, well, the best way is just to go 8 times what? 2, right, which is 16. Well, it depends what you're finding, right? They told you AZ, the whole thing, right? So if you divide that by 3, that gives you the shorter one, okay? And then once you know the shorter one, how do you find the longer segment? Just double it, right? Multiply it by 2, good. And then you get 16. Does that make sense? All right, so that's kind of what they do. Now, if you look in the book, they do this thing where they talk about 2/3 and 1/3, but this is 1/3 of the whole thing, isn't it? It's the whole thing divided by 3. That's 1/3. All right? And this would be how many thirds? So it'd be 2/3, right? So this is 1/3. This is twice as much, which would be what? 2/3. So if you look in the book, they talk about 2/3. So if you look at it, you're like, oh, he never talked about 2/3. That's what it is. I just don't like to talk too much about the 2/3 because it makes it a little more complicated. All right, so here's what you're doing for homework. I'm going to add a little bit to what's on the lesson plan because I only had you do 1 through 7 on the other one. So we're doing 8 through 12, and then we're going to go 23 to 37. Okay, and this is section 52B, and it's pages 217 to 18. Pages 217. Look at that timing. Perfect timing. Yeah. If you want to take a picture of it, you can take a picture of it. So that's due tomorrow. Have it done for tomorrow.